Okay, so here we are with the 2.5, 2.6 video for general chemistry. It has to do with density and percent error and percent yield. Maybe not percent yield yet. Maybe that's next semester. Anyway, density, mass, or volume. It's mass over volume, so if you have this formula memorized, that should be all you need. Density is mass over volume. It's grams per milliliter is the unit. And if you notice, it's grams divided by milliliter. It's mass divided by volume, so mass divided by volume. Hopefully your algebra skills are adequate. Mass versus weight. So mass is the amount of matter. Weight is the force of gravity. So if the force of gravity changes, the weight will change. Whereas if the force of gravity changes for mass, the mass won't change. Here on Earth, we measure mass by measuring the weight, because there's a ratio on Earth, the 9.81 meters per second squared, acceleration due to gravity, etc. There's a relationship on Earth that we've grown accustomed to, so we can just put it on a scale. But if we were in a different planet or something, you'd need a different scale, but we're never going to do that. At least, I don't think in our lifetime. So for us, it doesn't really matter what the difference is. But please just know what it is. We really only work with mass in chemistry class. We're not going to use weight here. But you're made out of the same amount of stuff if you go to the moon. You just weigh different amounts. Anyway, you know what volume is. And you should know how to measure the volume of liquids, regular solids, and irregular solids. We did this in a lab. Liquids, you just use a graduated cylinder. Regular solids, you can use geometry and a formula and calculations. Irregular solids, you have to do displacement. You could do regular solids and displacement too if you felt like it. Mass over volume, blah, blah, blah. Box A or box B? Box A is more dense because there's more mass in the same volume. There's more stuff there in the same volume. It's more dense. Suppose we had an object with a mass of 25 grams and a volume of 32. So remember, if it's grams per milliliter, we take the grams divided by the milliliter. So it's 25 grams divided by 32 milliliters. And if we look at this, hey look, there's our unit right there of density, grams per milliliters. This is why I stressed this when we talked about dimensional analysis, because it's helpful and it makes a whole lot of sense if you understand it correctly. So when I do 25 divided by 32 and I get 0.78, 0.78 grams per milliliter. What's the mass of 50 milliliters of water? Please remember that the density of water equals 1. Density of water, and this is technically at 4 degrees Celsius, but whatever. This is 1. This is basically what these things are based off of, is the density of water. So however many milliliters you have, that's the exact same number of grams. So we have 50 grams of water if we have 50 milliliters of water. Looks like this icon is here. I can just clear it and move on with my life. 3, given that the density of iron is 7.9 grams per cubic centimeter squared. I should probably tell you this too. Cubic centimeters is the exact same as milliliters. They are the same. So 3, given that the density of iron is 7.9 grams per cubic centimeter, what would be the volume of a 15.8 gram piece of iron? So here's where it might get mildly confusing. Density is mass over volume. We have the density and we have the mass. So 7.9 equals 15.8 over x. We don't know the volume. So the first thing you're going to have to do is cross multiply. So pretend this is over 1 and cross multiply. So it's 7.9x equals 15.8. Do a little bit more algebra. Divide both sides by 7.9. And to me, it looks exactly double. So our volume is going to be 2 milliliters, which is the same thing as cubic centimeters. So I don't care how you say it. 4, find the density of a block with a length of 4 and a width of 3. Well, what's the height? And we don't have mass. So that is not enough information. Remember those questions? Those were fun in middle school. Okay, now calculating percent error. So this one we've already done once in lab. You have to take the value that you got during your experiment and subtract that from whatever the textbook says it is or whatever the right answer should have been. You don't actually have to do the subtraction. It doesn't matter whether it's positive or negative because it's the absolute value. Then you divide it again by what the textbook says, or the real number, so that you can basically account for the fact that the real number is what it's supposed to be. So just subtract the two numbers, divide by the accepted number, and then make sure it's not negative. So in a lab experiment, you're told by your teacher that the actual or accepted amount of sugar in a can of Coke is 39 grams. You experimentally determine it to be 40, so just find the difference. So the difference is 1, obviously, right? It doesn't matter whether it's positive or negative, just make it positive. 40 minus 39, absolute value bars. Okay, then you divide it by the accepted value again. So that's 39. And then you have to multiply it by 100. In order to get it in a percent form. If you don't multiply it by 100, it's going to be out of 1, and you're going to get a bad, incorrect, not bad necessarily, but an incorrect answer. So 1 divided by 39 times 100 is 2.56% error. This person was off by 2.56%. Good, useful information. Blah, blah, blah. Now you have Schoology homework. Great job, everybody.